Hello, and welcome back for more Beyond Earth news. I'm David, and with me, as always, is my co-host, Zach. Zach, can you tell us what we're going to talk about today?
Yep, we're going to be discussing the Cygnus cargo mission to the International Space Station called NG-21. By the time this video releases, it probably will have flown, though it hasn't launched yet. And specifically, we're going to be talking about the biotech experiments on board from the company Redwire Space.
Excellent. Let's dive in for more.
The Cygnus flight is part of NASA's regular resupply of the International Space Station. Cygnus craft are constructed by Northrop Grumman and are named after former NASA astronauts. In the case of NG-21, the cargo craft is called the SS Francis R. Dick Scobie, named after the astronaut who lost his life in the Challenger disaster of 1986. The Cygnus is launching on a SpaceX Falcon 9. The launch will be from Space Launch Complex 40 from Cape Canaveral Space Force Base in Florida. After separation from the rocket, the Scobie will spend about 2 days in transit to the ISS before it is captured using the station's robotic arm and berthed to the station. It can then be unloaded of its 3,700 kilograms or 8,200 pounds of cargo.
Alongside the normal supplies, such as food, NG-21 is also carrying several biomedical experiments from Redwire Space. For example, Redwire's Belgium team has created the Colloidal Solids Instrument for the European Space Agency. Called COLIS, it will investigate the origin, formation, and dynamics of proteins, colloidal glasses, and gels. The experiment has two different cell modules labeled Cell Module D and Cell Module E.
Cell D will look into protein crystal nucleation. Crystal nucleation is one of the more mysterious processes in physics, chemistry, biophysics, and biotechnology. Nucleation is an important step in the self-assembly processes of diseases such as Alzheimer's, Parkinson's, and Huntington's.
Cell E will look into more fundamental research. Colloidal suspensions are of interest to many different industries, and scientists are interested in colloidal systems because they mimic more complex molecular systems. Colloids are used as thickening agents in industrial products such as lubricants, as well as toothpaste. They also play a role in the transfer of nutrients and pollution in the environment, and can be used as a suspension to improve drug chemical stability.
Redwire will culture 36 3D bioprinted liver constructs inside the company's multi-use variable gravity platform on the ISS. This is being done to see if liver cells printed on Earth can form fully functioning blood vessels in a microgravity environment. Redwire wants to improve 3D bioprinting technology with the hopes of one day being able to print fully functioning organs. This is so that they can tackle the world's organ shortage. Redwire is working hard at developing biotech, with the company having printed a knee meniscus and heart tissue in the past 12 months.
Finally, 4 drug manufacturing experiments are being carried out as well. The experiments will be conducted in the company's Pharmaceutical In-Space Laboratory Biocrystal Optimization Experiment, or PILBOX, system. This will be the third delivery to the system in 10 months. PILBOX is helping find treatments for ailments such as diabetes, cardiovascular disease, and pain.
So we have cargo and experiments on Cygnus cargo mission NG-21. A lot of biotechnical kind of research going on there. Any of that spark interest with you?
Absolutely. In particular, the research on Alzheimer's and Parkinson's and Huntington's, that's all super important, and I can't wait to see where they're going to go with all of that. Everything else sounds really interesting too, so I'm anxiously awaiting some updates on that. What about you?
Yeah, I find the 3D printing aspect to be particularly interesting. Just 3D printing in general is pretty new, and here we are already talking about, oh, I need a new liver. Okay, let's whip one up, let's print you out a liver, and you're good to go. And hopefully no more waiting for years for a transplant. Wondering if you'll live long enough to even get one. Now you can, I guess, have one almost custom ordered to fit your body in particular.
Absolutely.
Hopefully that would get rid of any sort of organ rejection. If you happen to get one that your body just doesn't like, order up another one, print out another one. So all of that is very interesting, and that's what I'm really looking forward to, is just how that technology develops and where we go from there. But then obviously we want to hear from our viewers. Let us know what you found interesting about this particular topic, the disease research or the bio 3D printing. Let us know in the comments down below.
And as always, if you've made it this far, please like, comment, and subscribe.
Thanks for watching.